Cool. All right. So here we are. Yeah, so we should be recording. So whenever you're ready.
You ready?
Yep.
So I'm going to start. Well, hello everyone. I'm the owner of Eggplant, which is ergonomic API crate for egglog. And here I will bring some points that Eggplant can make use development to speed. And part of the name Eggplant is the combination of two words EGG and the plans. EGG means it graph boundaries that which is to optimize IR, and the plans is makes this from the creator of EGG. And here I'm going to split the theme into three parts. As you can see, we thirdly will get the quick view for Eggplant API and the viewer, and then the graph variant supports by this ergonomic API. The first part of the API, you see the list about the container type, DSL, define API, and so on. And I don't want to talk about this because I think this is too long. I will just pick some important ones to talk about. Yeah, this is the DSL define API, and you can see this expression has been split into 5 variants, which it can be a constant, can be a multiply operator, or sum, or add, divide. And you can see that the constant can be specified directly by a Rust object I64, and it can be used directly on this API on the right hand. You can see that we just define add with it can be calculated to be 10 easily, and we just commit this API. Yeah, you can see node is committed in this last one line of the code, and here we can see this user type. What is user type? That means that we can define the type out of eggplant crates or egglog space. This is the user's own type, and you can see that we just define an operator. This is the contents of uh, five variants. You can see add some multiply, division, and unknown. Well, unknown is going to be removed in next several versions, so I will not talk about this. And this API means that we can directly embed some important base type to your DSL, which is quickly. And here, I want to introduce the query API. Yeah, this is the most important API ever created. And you can see that the generator can be propagated from the query closure to the action closure, which is the most convenient. You can see that we just define a graph in the query closure. This is an add pattern which consists of two constants, and we can just make some predication on this const. For example, here we just point to 100, and the number should be less than 100. And then we just catch the variables and pass it to the egglog, so that it will search for all the patterns available. And then we can do actions here in the action closure. You can see that we just define the constant propagation rule here, and we can just get the value of every add pattern. That means we can do some fuzzy search on the egglog graph, which is crazy. And to make the debug procedure more helpful, we just make a viewer. You can see this viewer. It consists of two panels. The left hand is the graph, and the right hand is the node detail of the node you clicked. And you can also see some classes and nodes in the left and right graph. Also, since the eggplants also support all of the other variants such as slotted graph, so we can define the slotted graph viewer singly. You can see that the graph is different from the former, and I will talk about the slotted graph in the next part. Yeah, and we can also define our UI in the user space, which is defined by your and not by the prelude. This might be helpful if you want to, for example, just click the node and you can see the CUDA code of this node represents. And then in future, I will add more features on the debugging. For example, we can support loop debug with for example, you want to have this rule running, or we can just turn this rule off so that we can check whether some rule is wrong or blah, blah, blah. And we can also support the graph record and rerun. So record means that we can check for every step of the graph running. And rerun makes us to think about which part make me the performance slow. And also, we can show a visual proof of the node you pointed to. And that is the variants we talk about mostly. For example, since they are pushing the graph forward, the academics, so you can see different graph variants. For example, such as here we just imported the slotted graph, which means that you can erase the alpha equality of the graph. The left-hand side is the vanilla graph, and this is the initial one. We can do some transformation to the slotted one with less node and more density of information. So to implement slotted graph, we can use some hooks. For example, here we just define 3 hooks: insert, union, and flash pending. And use 3 hooks, you can just make the vanilla graph into the slotted graph. And use the base type define the API that we can do some specifications of the node so that we can store additional information to your DSL. And this makes the transformation into possibilities. We can just see that we define the hashing and partial equality for the slot meta. And by using this 2 traits, we can make the egglog know that we can eliminate all the slot meta with simple hashing. And this is helpful in removing the redundant node. And then we just embed the metadata into the expression, which is our DSL. And you can see that we just also add attributes for variable. By using this and other some methods, we can just make the vanilla graph into the slotted graph, which is quite beautiful, I think. And last, thanks everyone related to this repo.
Awesome. Well, this is great. Thank you. I have a couple questions that came up during the talk, mostly about like Well, I mean, why did you want to make like a Rust-based API as opposed to just using the Lisp egglog syntax directly?
I think there's two ways I like to talk about this. Is firstly the flexibility. We talk about flexibility because our Rust native type can be directly used in egglog code. That means we can do some native operations on the egglog's DSL. And the other side is that for debug, and we can see that I created two viewer for the graph, and I want to make the procedure more smooth. Yeah, I think this is the two main reason I'm searching for. Yeah.
Now, this viewer, does this hook into Eggplant before it ends up going into egglog, or after? Does it actually export the serialized egraph and then produce that view?
Yeah. Currently, we just make the serialized one into the graph view, but I think in future, surely I will add for example, the real-time interaction on the view.
Mm-hmm.
Yeah.
Awesome. You showed the rule API, so how you can define queries and then actions. Do those support rule sets?
Sure. For example, here we can just see the rule set identifier. Yeah.
Yeah. And then we can define, does Eggplant support like schedules yet for running these rule sets?
Yeah. Which is similar to Agros code like schedule,
Okay, great, awesome. And then that add pattern, that is how you basically package information to then send to the action so that you can use it inside the action. Is that right?
Yeah, this is just like the CUDA graph. You just record the graph, and we'll use this graph to query the corresponding pattern in the graph.
I see. Now, does this get directly does this ever go through like an intermediate layer where it gets rendered into egglog code and then fed into egglog, or do you interact directly with the internal egglog APIs?
I think do you mean this closure, the action closure? We can directly use some Egglogs API in this this closure, and this is in the Egglog space. That means we can do some additional operations, such as we can use the value to get the internal value of the identifier. Yeah.
I see. And so when it's actually doing the saturation, it's actually running these functions. These aren't just specifying some IR and then feeding it off to egglog. Like these are actually getting ran, and so that print line is going to be ran like every time a constant fold is done.
Yeah.
I see. Cool. Yeah. I mean, is there any features that you think that egglog supports that Eggplant doesn't support yet and that you want to support?
I think about naturally egglog is my upstream, and I should use its API definitely. And I want to add some more features than egglog because just think this project is complete and don't want to add more features.
Sure. Yeah, totally. Have you found this to be like an easier way to build very complicated patterns rather than just go directly into egglog and do that?
I think this crate can currently cooperates with egglog code.
Yeah.
That means we can incrementally build this, replace the egglog code into this crates. For example, we can just write the vanilla egglog code, egglog code here and run the rule sets, and that's not a big deal. Yeah, I think.
Yeah, no, that makes sense. On the slotted e-graphs, do you want to just like do a quick high-level overview of how they work as opposed to a traditional e-graph, and then like talk a little bit about how you implemented that? Was it implemented on top of egglog, or was it like a sort of like side separate thing?
Well, this is a little complex. I think this should you should visit my website to know how this can be implemented. I will release the code in next several weekends so that you can find out how I implemented this.
Okay. What's like the main benefit of slotted e-graphs over traditional e-graphs?
For example, you can have two variables. They can be exchanged just like, for example, A add B, and you just write a pattern to exchange them, and you generate the node B add A. This will create two different terms, which is I think is redundant, and we can just use the duplicate node to replace the true term so that we can compress the storage.
Well, I guess that would also reduce the possible matches downstream if you have, one representation instead of two for the commutative case.
Yeah.
Wow. Cool. Yeah, great. Well, I mean, those are the main questions I had. Is there anything else you wanted to talk about?
Yeah, I think Luminous DSL is quite interesting. Well, first I on it, I think it's how beautiful. Well, you can just do the pattern match of loop DSL on the DDAG. This is hard to say, I think.
Yeah.
I did see some DSL like JVM DSL, and they just use a long side effect chain to chain the loops, and which looks very terrible. This is hard to optimize, I think.
Yeah. Yeah. I agree. That makes sense. Cool. Yeah. So, I mean, I think that as far as I definitely want to try Eggplant out. And I think that's kind of been like a thorn in our side that we have to switch between most of our code base and Rust, and then having to write a lot of like Lisp style egglog. And then there's a lot of like um, we can't really unit test the rules that we write very well because it's in egglog language. And so I think if it's possible to write a lot of these rules in this Eggplant API and in such a way that they can in the future somehow be unit testable, because ideally, like, you screw up a rule and like it is actually very difficult because it's got a bunch of side effects downstream. So it's actually pretty difficult to debug. So yeah, I think that we definitely are, pretty excited that maybe we can implement some of our rules or all of our rules directly in Eggplant, and then maybe even there's some performance benefit there because we don't have to go through this intermediate layer of the egglog syntax, which currently we have to render our graphs into the egglog code and then feed that to egglog and then serialize and get it back and then do our extraction. So
Yeah, I think this is a big step. Thank you.
cool, awesome. Well, thank you so much. This was great. All right. So if anybody has questions, post them in the Discord. We'll be in there. But yeah, this is probably one of the first of many, I'm sure, talks that will be given about luminal or adjacent technologies like Eggplant here. Yeah, so do you want to put your website back up again, just for the end, so that people can go to it?
Yeah. Just there are
Awesome.
3 pages about the implementation, and I recommend there are two articles about this, I think.
Awesome. All right, so I'll post that link as well. Yeah, everybody should go check that out. Cool.
Yeah.
All right. Well, thank you so much for giving this talk.
Yeah, thank you very much for recording this.
Sure. All right. Have a good one. Bye bye.